The DNA tells our body what to do on the cellular level, like telling our proteins what to do. It is the code that our bodies rely on to function, the essential instructions needed to survive. It controls major functions at this level, but also controls outward. The DNA controls our physical appearance, our traits. It what makes you really you. Without this genetic code, everyone would be the same. Though, that wouldn't be possible because it is needed to survive. But before we get into that, let's start with the basics.
Much like everything in the world, the DNA is made up of smaller things, being nucleotides. The nucleotide is made up of even smaller things as well, being sugar phosphates bonded together, but there is a final, more important part, being the nitrogenous base. I am Nadim Rahman. My parents are from Pakistan and they immigrated here before I was born. I have a mother, a brother, and a sister. All of my siblings are older than me. My mom is very sweet. She wants the best for us. My mom loves music in her native language and foreign languages from the area of Pakistan. I enjoy them as well. My community, more specifically my neighborhood, is surrounded by many people who check up and make sure you're okay. My neighbors always greet me with a smile and improve my mood. My core values include being kind to people and treating people the way they want to be treated. I think that one of my genetic traits, my skin being darker, is pretty important to me. My parents both came from an area that has extremely hot weather a lot of the time, and due to this, my darker skin, having a bit more melanin, is great for the sun. I find this matters a lot to me as I really enjoy summer and going outside, and knowing my skin can withstand the sun naturally makes me feel a lot more happy.
I'm Keo. My dad's from Sweden and my mom's from Florida. My core values include being kind and loyal to people in my family. My family consists of my mom, my dad, and I have a younger brother. Our chosen similar trait is hair type. We have similar hair types, and we chose this as the trait to narrow our research. But how does DNA affect the body? On what level is it? What effects does DNA have that in turn affects something else? How far does the effect of DNA reach?
The levels of organization depicts this very well. They, for DNA more specifically, in an organ such as the liver, stretch back quite far. DNA is a nucleic acid, one of the 4 types of macromolecules: carbohydrates, proteins, lipids, and nucleic acids, and it is in the mitochondria, which are organelles of the cell hepatocyte. Even further on, the hepatocyte is a cell that makes up the liver's epithelial tissue. The DNA is very important to the body, our bodies, as the liver is part of the digestive system, which is a major part of the bodies of Keo, I, and every human on Earth.
Here's our completed drawing of the DNA. As you can see, it is complete with all the nitrogenous bases.
So our chosen shared trait was a similar hair type. Transcription occurs in the nucleus. It's the process by which the DNA is unzipped and read. When the DNA is unzipped, its code is copied to RNA, and then this RNA leaves the nucleus, then the final stage of transcription occurs, and the RNA is then zipped into an opposing band. Translation, on the other hand, occurs in the nucleus, as this is where the DNA is translated. mRNA, tRNA, and ribosomes all play different purposes. mRNA is a messenger mRNA, or messenger RNA, and it carries the code of the DNA. tRNA is transfer RNA. It carries amino acids in the form of an anticodon to an mRNA codon. It also carries matching nucleotides to the mRNA codon and attaches through base pairing. Finally, ribosomes hold the tRNA and mRNA inside and wait for the tRNA to fill slots in the ribosome. As this is done, the amino acids of the tRNA link to the polypeptide chain, and by doing so, a polypeptide chain is formed that mirrors the codons in the mRNA. In the end, the product that is formed is a protein.
How do our bodies respond to a winter climate? The body needs to take in energy from food, more specifically proteins, as they support the body in a variety of different ways. The biochemistry of this starts at the food being eaten, where then it is digested and the energy of it is taken out of the food and transferred to the body. The cells of the body work to break down the food into its core components. After it is broken down, the components act as nutrients that are then used in positive ways throughout the body.
After careful consideration, we have decided that your DNA does not define who you are statically. The body. The human body is an adaptive and changes based on many things such as the environment. The body itself responds to stimuli and tries to maintain homeostasis. In counter-argument to this, one could say that the DNA causes the human in question to respond in the same ways to the same things. But twin studies disprove this. Twin studies show that external factors like climate and social interactions matter. Depending on the environment, different genes can be turned on or off. Because of this, it shows that DNA is not the only factor when it comes to twins not being perfect one-to-one copies when they grow up. The genes turning on and off are what affect this. Though I don't directly relate to twin studies, I find it eye-opening as I do have siblings, and I wonder if the same things seen here apply with family members born years apart.
It shows that my identity and other traits can change as my life progresses.
I think that I may not be too well off. I need to change some of my habits.
My habits and life aspirations change my environment. As stated earlier, these changes in the environment can toggle my genes and change my personality and traits.
We land on the nature versus nurture spectrum that DNA does not fundamentally define who we are or what we end up doing in life. Rules of nature are that living things immediately say that the body responds to stimuli and external factors such as climate. The DNA itself cannot control what someone does in their life, and as stated previously, it is due to genes turning on or off, which in return is due to the environment.